Hello everyone, welcome back to the channel. Thank you so much for joining me. So today I wanted to share my perspective on what is data engineering. Especially for newcomers, it can be really confusing. Like, what exactly do you do in a role as a data engineer? So in short, data engineering is about creating and managing the flow of data for analytics. So today I'm going to take a little deeper dive into the different components and aspects of data engineering. So please like this video, comment on new video ideas for me, and subscribe to get more content like this. And please share this video with anyone you think this would be helpful to. All right, come on, let's go and explore the different aspects of data engineering.
Data pipelines.
So data pipelines. Data pipelines are a very important aspect of data engineering. So data pipelines are all about ETL, or extract, transform, and load. Taking data from a source system, transforming it if necessary, and loading it into a destination system. An example could be taking data from a Postgres system, converting it to a Parquet file format, and loading it to some cloud storage like S3.
Data orchestration.
Data orchestration. Data orchestration is about creating the flow and scheduling of different data pipelines. For example, creating a sequence of data pipelines to run, or scheduling a data pipeline to happen at a specific time or cadence. Some examples include like creating Airflow DAGs or creating AWS step functions.
Data modeling.
Data modeling. As a data engineer, you might have to modify or transform the schema of the data to fit the analytics needs. Examples might be, let's say you have data in a relational Postgres system, and you want to move to a NoSQL, non-relational, like columnar system like Cassandra. So for this, you would have to use query first design, where you design your data tables based on the analytics queries. For this, you might have to flatten some of the data tables, get rid of some of those relation tables to reduce the number of join operations that you need to do. Other examples are data warehousing with the star and snowflake schema using fact and dimensional tables. Basically, what you're trying to do is make sure your data is in the right format for analytics processing rather than transactional processing.
Data collection.
Data collection is also an important aspect of data engineering. Examples could be setting up Splunk, Logstash, or Kinesis agents on the web server where your application is running. You could be sending clickstream analytics data to a Kinesis streaming application. You could also be using Logstash to send log data to an Elasticsearch cluster for further analysis. You could also write like a web scraper to get the required information for your analytics.
Data storage.
Data storage is also a very important aspect. Storing the data in multiple locations or file formats. For example, in the cloud, it could be AWS S3, Azure Blob Storage, Google Cloud Storage. You could be storing in a relational system like Postgres, MySQL, or Oracle. You could be storing the data in a non-relational system like Cassandra or MongoDB. You could also use multiple file formats. Examples of like a columnar format, which would be like Parquet or Avro, or you could be using JSON or CSV.
Data validation.
Data validation is also a very important aspect of data engineering, using tools such as data profiling, unit testing, and data quality checks to ensure that your data is accurate before you hand it off to downstream analytics systems. Data profiling is about getting different statistics about your data. For example, what is the null count percentage for a column? What are the different data types of your columns? What is the min, max, etc. Data quality checks are more about kind of like integration testing, making sure that the transformation happened correctly, making sure there are no duplicate values in your data, or if you have certain specific scenarios that have failed in the past, checking for those. Then unit testing, for example, you could be unit testing certain Python functions that are used as UDFs to make sure that transformation is happening correctly. And the beauty of unit testing is it happens before your code goes anywhere, before your code is pushed into a processing environment, so you can catch it very early. So all these tools are very important to making sure that your data is accurate before handing it off.
DevOps or DataOps.
DevOps or DataOps. DevOps is a completely separate role, but elements of DevOps could be part of your data engineering role. Examples include like creating the cloud infrastructure for data processing. You could be writing some Terraform code to bring up an EMR cluster, or to create a step function, or to create a Lambda function that triggers whenever a file is put on an S3 bucket. Or you could also be creating like a CI/CD pipeline that creates the code artifact for your Spark code, and maybe run some automated unit tests, and pushes it to S3 or pushes it to some sort of repository.
MLOps or ML engineering.
MLOps or ML engineering is also a completely separate role, but as a data engineer, you could be doing part of this. So this involves working with data scientists to make sure their ML models and systems are integrated to the application. So you could be doing some sort of containerization for maybe like TensorFlow or PyTorch code, and create like REST APIs so that the application can get the predictions from the machine learning model. Or you could write like a Spark data pipeline using like MLlib that does this machine learning prediction in a batch format. So basically like working with the data scientists to take that machine learning work and integrate it with the application.
Monitoring and alerting.
Monitoring and alerting is also a very important aspect of data engineering. You want to know when your data pipelines are failing or data processes are failing. So you could be setting up systems like PagerDuty that will, basically call the responsible engineer whenever a data pipeline goes down. Or you could, configure your data pipeline to send a Slack alert or a Mattermost alert to like a channel that alerts all the engineers on the team. So some sort of system that alerts engineers when the data pipeline or data process is down, and you can fix it as quickly as possible.
Technologies.
So the technologies for big data and data engineering are changing every single day, but just wanted to give an example of some of the commonly used technologies today. So for data processing, of course, we have Spark, and then Hadoop, Hive, SQL, and then Apache Beam. And then for some of the data processing platforms, we have AWS EMR, Databricks, Snowflake, then some of the commonly used programming languages, Python and Scala, and then some of the data storage technologies, S3, Azure Blob Storage, Google Cloud Storage, Postgres, MySQL, Oracle, Cassandra, Elasticsearch, MongoDB. The list goes on and on. So, basically you have to try to figure out what is the right technology for this scenario. But there's a lot, and the ecosystem is growing every single day.
Collaboration and integration.
Collaboration and integration is also very important. Working hand in hand with the software development team on the application side to make sure the data is flowing through correctly for analytics. Examples like if a data schema change has happened, making sure that the data pipelines are also updated with the correct schema for the source system. Things like you might also work with the application team to improve the DB performance, examine, why certain queries are, running very slowly. Basically working hand in hand with the software development team to make sure also that the flow of data for analytics is not breaking down.
Conclusion. Also, check out the links in the description.
So data engineering is a very broad field and it varies from company to company. But I hope this video gave you more insight and clarity on the different aspects of data engineering. So yeah, thank you so much for watching this video. Please, like, comment on more video ideas for me, subscribe for more content like this, and share this video with everyone that you think it would be helpful for. And yeah, thank you so much, and I'll continue to make content like this for you.